Hello, I'm Delaney Story, and I'm here to report on our Mission 7 flight experiment. I would like to acknowledge that my recent partners, Kylie Morton, Bryson Baker, and Wesley Mitchell, could not travel with me today. I'm from Burleson Independent School District, and in the making of this project, I was a 5th grader at Academy at Nola Dunn with my teacher facilitator, Susan Munch. My group watched many videos on everyday life, using water, of course, on the ISS. We are very fascinated by this and had lots of questions about how water works in microgravity. This led us to wonder how water is stored, reused, and absorbed. The purpose of this experiment was to observe the absorption of polymers rate in microgravity. Polymers are an important material as they are used in a variety of items. They can be found in credit cards, bottles, spandex, eyeglasses, and most commonly found in diapers. It is important to study the polymers as they could one day help in the future. We propose to answer the question of what hydrogel polymers will do when mixed with water in microgravity. Our research into polymers has shown us that polymers are capable of absorbing and holding large amounts of water on Earth. The amount of water absorbed relies on the ability of water to diffuse. Since diffusion is the breaking apart of water molecules, gravity seems to play. While we think that the water will still be absorbed in space, we believe that the diffusion process would be slower, which would make the amount of water absorbed less in microgravity. The materials we used were 2 grams of hydrogel polymers, a Type 2 FME mini lab, 2 plastic faucet aerator screens by Neopearl, 2 milliliters of local Burleson, Texas tap water, and 3/10 grams of one piece of cotton ball. So as you can see on the ground truth mini lab, there are more polymers on the Earth. And as you can see on the International Space Station, more polymers, more water was absorbed. So on the ground truth lab, it looked the same. The cotton was a bit moldy and many granules left. Granules did not absorb the water and weighed 24.2 grams. No gel was formed and there were many dry polymers. So on the space station mini lab, the tube had expanded, the aerator had moved, and cotton was very moldy and wet, and granules completely absorbed, gel was present, weighed 25.1 grams, and formed a very distinct shape. So in conclusion, we are fascinated by the extreme differences in the mini labs. We noticed that we were incorrect on our hypothesis, and the polymers in space would hold less water, and the exact opposite happened. The absorption of polymers in space is completely different than the process of absorption on Earth. In space, the polymers absorbed far more water than on Earth. The water vapor in space was enough for the polymers to absorb, but not on Earth, and diffusion does occur more quickly in space. We believe that the polymers absorb more in space due to less gravity, and that the process of diffusion is quicker. It is easier for the polymers to do their job in space. Our original thinking was incorrect, and that quick absorption of the polymers will be extremely helpful one day to those living in space. It is a more efficient method than other materials. We believe it is something that should be studied more in detail. And I would just like to thank everyone who made the SSEP program possible. Thank you.
Do we have any questions?
Hello, I'm Ross Rutherford from Seattle. So do you believe that there will be any irregularities present in Burleson, Texas tap water that may differentiate from the standard water that could perhaps be used in future missions?
There could be. I'm being really completely honest. I honestly wouldn't know, but there could be.
Hi, I'm Vivian Rutherford, also from Seattle. What do you think is the importance of having polymers in space?
Well, it would be really bad if some water got out and it would affect the technology, if it could mess up any technology. So the polymers, since polymers can be found in diapers, maybe a more sufficient way you could use diapers and polymers and stuff.
I'm Audrey Whitmer, also from Seattle. So you're suggesting that instead of just having water in containers, we have it in polymers, certain polymers?
Well, no, if water gets out, we could use polymers to maybe absorb the water just in case it does get out.
So this is a sort of emergency
This could be an emergency
collection
plan.
system, okay.
Yes.
Thank you.